Hello and welcome everyone to Science Era. In this video, we're going to discuss Chapter 4 of Chemistry OpenStax 2E. This video will focus on writing and balancing chemical equation as well as the equations for ionic reactions. So let's begin. Writing and balancing chemical equation. When you look at a chemical equation as whole, you will find four things common in every single type of chemical equation. There will be reactants, there will be product, there will be a plus sign, and there will be a arrow. So reactant, when you say reactants are substances which react to form product. So products are substances, they are generated by the reaction. When two reactant react or two or more reactant reacts, they form a product. Reactant is always written on the left hand side of the equation and product is present on the right hand side of the equation. Okay, so these are the reactant on the left hand side and these are the product. Both of them are the product on the right hand side, right? The plus arrow, plus sign here and here separates the product and reactant. How many reactants are reacting to form two products? Methane and oxygen in this chemical equation are reacting to form two products, which is carbon dioxide and water. Another thing we need to notice in a chemical equation is coefficients. Coefficients are the relative number of reactant and product species, right? Or we can say that number placed immediately to the left side of the formula. If the coefficient is 1, for example here in methane the coefficient is 1, it is omitted. In carbon dioxide the coefficient is 1, it is also omitted because it is obvious there is no sign, no coefficient present, there is only one molecule of carbon dioxide and there is one molecule of methane. Methane and oxygen react to yield carbon dioxide and water molecule in the ratio. From the coefficient we can see or we can figure out or we can write the ratio, right? So if we say that 1 is to 2 is to 1 is to 2, right? So these are the ratios for the reactant and these two are the for the product. So methane and oxygen yield carbon dioxide and water in a ratio 1 is to 2 is to 1 is to 1. We can say this in another way. One methane molecule and two oxygen molecule react to yield one carbon dioxide molecule and two water molecules. I am saying the same thing, that these ratios is 1 is to 2 is to 1 is to 2, but in another way. Another way of telling or presenting this information is 1 dozen methane molecule and 2 dozen oxygen molecule react to yield 1 dozen carbon dioxide molecule and 2 dozen water molecules, or 1 mole of methane molecule and 2 moles of oxygen molecules react to yield 1 mole of carbon dioxide molecule and 2 moles of water molecule. Always remember, regardless of the absolute number of molecules involved, the ratio between number of molecules of each species that react or the reactant and molecule of species that form, which mean the product, are same and are given by the chemical equation. So they are always same regardless of the absolute number of molecules involving. Next concept we're going to discuss is balanced equation. When writing a chemical equation, we must make sure that it is always balanced form. What does balanced mean? Balanced mean that equal number of atoms of each element is involved in reaction and are represented on the reactant and product side. So on the reactant and product side, there should be equal number of atoms present. For example, if we look at the last chemical equation, in which we said 1 mole of methane molecule and 2 mole of oxygen molecule react to yield 1 mole of carbon dioxide molecule and 2 moles of water molecule. The table provides the summary of how product and reactant are balanced on the either side of the equation. If we look at each element involved in the chemical equation, which is carbon, hydrogen and oxygen. Carbon, hydrogen and oxygen. Carbon on the reactant side, this is carbon and this is carbon on the product side. There is only one carbon on the reactant side and one carbon on the product side. So we say that carbon element is balanced. So we say yes, it is balanced. Next we are going to look at hydrogen. This is H stand for hydrogen. 4 atoms of hydrogen on the reactant side and 2 atoms of hydrogen times the 2 coefficient in the product. So 2 times 2 is 4. So we know that 4 hydrogen atoms are present on the product side and 4 hydrogen is present on the reactant side. So we will say that hydrogen is also balanced. Next we're going to look at oxygen. This is oxygen on the reactant side and there are 3 molecules of oxygen on the product side. Is it 3? Let's look at it. 2 times 2, so if we multiply the coefficient with the atoms, number of atoms, it is 2 times 2 is 4. So we know that on the reactant side there is 4 atoms of oxygen present, right? As I said in the table, 2 times 2 is 4, and on the product side there is 2 atoms of oxygen with carbon dioxide and one oxygen atom in H2O, but we say that there is 2 molecules of water in the product. So 2 times 1 is 2. So we're going to add 2 oxygen atoms in carbon dioxide and 2 coefficient of oxygen in the water. We will say it's 4. 2 plus 2 is 4. So yes, oxygen is balanced. Therefore, this equation where methane and methane and oxygen reacts to form carbon dioxide and water is balanced. Let's look at the example. So this example asks you to write a balanced equation of molecular nitrogen and oxygen to form dinitrogen pentoxide. So what are we going to do is, in first step we're going to write an unbalanced equation of where nitrogen is reacting with oxygen to form dinitrogen pentoxide. So this will be N2 plus O2 for oxygen molecule will give you dinitrogen pentoxide. So dinitrogen N2 and O5, right? So this is dinitrogen pentoxide. Then we're going to count the elements on either side of the equation, on the reactant side and on the product side. So first let me write the number of atoms reacting. So there is 2 atoms, nitrogen and oxygen, right? On the reactant side, I'm going to write reactant side in blue. There are 2 nitrogen and 2 oxygen present. And on the product side, there is, I'm going to write product in green. So there is 2 nitrogen present on the product side and 5 oxygen is present on the product side. So if we look at nitrogen, so we can say that nitrogen is balanced but oxygen is not balanced. We're going to balance the oxygen. We need to balance the equation. In order to balance the equation, we're going to balance the oxygen atoms present in the equation. So if I say that there is 5 oxygen atoms in the product side, I can times oxygen on the reactant side with 5, which will give me total of 10 molecules, 10 atoms of oxygen on the reactant side, right? And to get the 10 oxygen atoms on the product side, we're going to times dinitrogen pentoxide with 2. So I times it with 2 and I got 10 oxygen atoms on the product side too. But now if we see, there are 4 nitrogen on the product side and there is only 2 nitrogen on the reactant side. So what can we do in this step? We can multiply reactant with 2, as well as we already know that there are 4 nitrogen atoms on the product side, right? It's already 4. So if I say 4, sorry, let me write it in blue. Okay, if I say I times nitrogen on the reactant side with 2, I will get a balanced equation with 4 nitrogen on the product side. So 2 times 2 is 4. 4 nitrogen on the product side and 4 nitrogen on the reactant side, right? And if I say oxygen, 10 oxygen atoms on the reactant side and 10 oxygen atoms, 2 times 5 is 10 on the product side. Thus the equation is balanced. Additional information in chemical equation. Physical state of reactant and product in chemical equation often are indicated with parenthetical abbreviation. For example, common abbreviations are for solid S, liquid L, for aqueous solution we use AQ, and for gases we use G. Aqueous solution are substances that are dissolved in water. For example, if you look at the equation, 2Na solid plus 2H2O liquid dissolved into dissolved to form 2NaOH aqueous plus H2O gas. This equation represents the reaction that takes place when sodium metal is placed in water. The solid sodium reacts with liquid water to produce molecular hydrogen gas and ionic compound sodium hydroxide. Sodium hydroxide is a solid in pure form, but it is readily dissolved in water. That's why sodium hydroxide, the abbreviation written with that is aqueous. Next is symbols. Special conditions necessary for a reaction are sometimes designated by writing a word or a symbol above or below the equation. Arrow. This is the equation arrow. So this symbol is above the equation arrow is known as delta for heat. So which means that this reaction is carried out by heating or in the presence of heat. Equation for ionic reactions. Before we start writing equations for ionic reaction, we need to understand 3 terms: molecular equation, net ionic equation, and spectator ions. What do you think is molecular equation? An equation in which formulas of compounds are written and as though all substance exists as molecules. It is called molecular equation. Net ionic equation. Chemical equation that shows only those elements and compounds or ions that are directly involved in chemical equation is net ionic equation. And spectator ions are ions that does not take parts in chemical equation. Let's look at an example. When carbon dioxide is dissolved in an aqueous solution of sodium hydroxide, the mixture reacts to yield aqueous sodium carbonate and liquid water. What they are asking you is write balanced molecular, complete ionic and net ionic equation for the process. So we begin by identifying the formulas for reactant and product and then arranging them properly in chemical equation form. So this will be written as, so carbon dioxide plus sodium hydroxide will give you sodium carbonate plus water. Notice that this is an unbalanced equation. Balanced is achieved easily in this case by changing the coefficient of sodium hydroxide to 2, resulting in the molecular equation for the reaction as given. So CO2 plus 2NaOH sodium hydroxide will give you sodium carbonate and water molecule. The two dissolved ionic compound sodium hydroxide and sodium carbonate can be represented as dissociated ion to yield the complete ionic equation like this. So they will give you carbon dioxide plus 2 sodium ions and 2 hydroxide ion OH minus will give you in the product will get 2 sodium plus ion in aqueous solution plus CO3 2 minus and water molecule. So this is the ionic equation. First we wrote the balanced molecular equation, then we wrote the chemical equation or complete ionic equation. Now finally identify the spectator ion. Remember, spectator ion is the ion that do not participate in the equation. So in this case, sodium in aqueous solution is the spectator ion. We remove it from each side of the equation and then generate the net ionic equation. So we're going to remove sodium from both sides, from the reactant side and from the product side, because in the reactant we had 2 sodium ions, in the product as well we have 2 sodium ions, so we know that this is the spectator ion as it doesn't participate in the equation, and we are left with the net ionic equation for the process. Let's review the steps involved in writing ionic equation. In first step, we write down the equation including the state of symbols. For example, solid, liquid, aqueous or gas. Then we identify the precipitate and aqueous solution. We balance the equation and then split the equation into the ions form. Only for the aqueous solution we do that. Then cross out the spectator ion. What is the spectator ion? Ion that does not take part in the equation is the spectator ion. Finally, we write the ionic equation, and if they have asked you to write the spectator ion, you write it separately, stating that this is the spectator ion. In the preceding example we studied, we know that the sodium was the spectator ion in the chemical equation, in which carbon dioxide was dissolved in aqueous solution of sodium hydroxide and mixture reacted to yield the aqueous sodium carbonate and liquid water solution. Thank you for watching. If you like my video, don't forget to subscribe. In the next video, we will be focusing on 4.2 classifying chemical reaction.